The Lockheed Martin F-22 Raptor is a fifth-generation, single-seat, twin-engine, all-weather stealth tactical fighter aircraft developed for the United States Air Force, USAF. The result of the USAF's Advanced Tactical Fighter (ATF) program, the aircraft was designed primarily as an air superiority fighter, but also has ground attack, electronic warfare, and signal intelligence capabilities. The prime contractor, Lockheed Martin, built most of the F-22's airframe and weapons systems and conducted final assembly, while Boeing provided the wings, aft fuselage, avionics integration, and training systems. F-22 Raptor and F-22 flies over Andrews Air Force Base in 2008. Celestial Air Superiority Fighter National Origin United States Manufacturer Lockheed Martin Aeronautics. Boeing Defense, Space and Security First Flight 7 September 1997. 21 years ago Introduction 15 December 2005 Status and Service Primary User United States Air Force Produced 1996 2011 Number Built 195, 8 Test and 187 Operational Aircraft 1, Program Cost is $67.3 billion, as of 2010 2, Unit Cost $150 million, Flyaway Cost for FY 2009. Developed from Lockheed F-22 developed into Lockheed Martin the 10th 44 Manta. Lockheed Martin FB-22. The aircraft was variously designated F-22 and F-A-22 before it formally entered service in December 2005 as the F-22A. Despite its protracted development and various operational issues, USAF officials consider the F-22 a critical component of the service's tactical air power. Its combination of stealth, aerodynamic performance, and situational awareness enable unprecedented air combat capabilities. Service officials had originally planned to buy a total of 750 ATFs. In 2009, the program was cut to 187 operational production aircraft due to high costs, a lack of clear air-to-air missions due to delays in Russian and Chinese fighter programs, a ban on exports, and development of the more versatile F-35. The last F-22 was delivered in 2012. In 1981, the U.S. Air Force identified a requirement for an Advanced Tactical Fighter (ATF) to replace the F-15 Eagle and F-16 Fighting Falcon. Codenamed Senior Sky, this air superiority fighter program was influenced by emerging worldwide threats, including new developments in Soviet air defense systems and the proliferation of the Su-27 Flanker and MiG-29 Fulcrum class of fighter aircraft. It would take advantage of the new technologies in fighter design on the horizon, including composite materials, lightweight alloys, advanced flight control systems, more powerful propulsion systems, and most importantly, stealth technology. In 1983, the ATF Concept Development Team became the System Program Office (SPO) and managed the program at Wright-Patterson Air Force Base. The Demonstration and Validation (DEM/VAL) Request for Proposals (RFP) was issued in September 1985, with requirements placing strong emphasis on stealth and supercruise. Of the 7 bidding companies, Lockheed and Northrop were selected on the 31st of October 1986. Lockheed teamed with Boeing and General Dynamics while Northrop teamed with McDonnell Douglas, and the two contractor teams undertook a 50-month DEM/VAL phase, culminating in the flight test of 2 technology demonstrator prototypes, the YF-22 and the YF-23, respectively. DEM/VAL was focused on risk reduction and technology development plans over specific aircraft designs. Contractors made extensive use of analytical and empirical methods, including computational fluid dynamics, wind tunnel testing, and radar cross-section calculations and pole testing. The Lockheed team would conduct nearly 18,000 hours of wind tunnel testing. Avionics development was marked by extensive testing and prototyping and supported by ground and flying laboratories. During DEM/VAL, the SPO used the results of performance and cost trade studies conducted by contractor MIS to adjust ATF requirements and delete ones that were significant weight and cost drivers while having marginal value. The short takeoff and landing (STOL) requirement was relaxed in order to delete thrust reversers, saving substantial weight. As avionics was a major cost driver, side-looking radars were deleted, and the dedicated infrared search and track (IRST) system was downgraded from multicolor to single color and then deleted as well. However, space and cooling provisions were retained to allow for future addition of these components. The ejection seat requirement was downgraded from a fresh design to the existing McDonnell Douglas ACES II. Despite efforts by the contractor teams to rein in weight, the takeoff gross weight estimate was increased from 50,000 pounds (22,700 kilograms) to 60,000 pounds (27,200 kilograms), resulting in engine thrust requirement increasing from 30,000 lbf (133 kilonewtons) to 35,000 lbf (156 kilonewtons) class. Each team produced 2 prototype air vehicles for DEM, VAL, one for each of the 2 engine options. The F-22 had its maiden flight on the 29th of September 1990 and in-flight tests achieved up to Mach 1.58 in supercruise. After the DEM-VAL flight test of the prototypes, on the 23rd of April 1991, Secretary of the USAF Donald Rice announced the Lockheed team as the winner of the ATF competition. The F-23 design was considered stealthier and faster, while the F-22, with its thrust vectoring nozzles, was more maneuverable as LL is less expensive and risky. The aviation press speculated that the Lockheed team's design was also more adaptable to the U.S. Navy's Navalized Advanced Tactical Fighter, NATF, but by 1992, the Navy had abandoned NATF production and procurement. As the program moved to full-scale development, or the Engineering and Manufacturing Development (EMD) stage, the production version had notable differences from the F-22, despite having a broadly similar shape. The swept-back angle of the leading edge was decreased from 48 degrees to 42 degrees, while the vertical stabilizers were shifted rearward and decreased in area by 20%. To improve pilot visibility, the canopy was moved forward 7 inches (18 centimeters), and the engine intakes moved rearward 14 inches (36 centimeters). The shapes of the wing and stabilator trailing edges were refined to improve aerodynamics, strength, and stealth characteristics. Increasing weight during development caused slight reductions in range and maneuver performance. Manufacturers of the F-22. Prime contractor Lockheed Martin Aeronautics manufactured the majority of the airframe and performed final assembly at Dobbins Air Reserve Base in Marietta, Georgia. Program partner Boeing Defense, Space and Security provided additional airframe components as well as avionics integration and training systems. The first F-22, an EMD aircraft with tail number 4001, was unveiled at Marietta, Georgia, on the 9th of April 1997, and first flew on the 7th of September 1999. Production, with the first lot awarded in September 2000, supported over 1,000 subcontractors and suppliers from 46 states. And up to 95,000 jobs, and spanned 15 years at a peak rate of roughly 2 airplanes per month. In 2006, the F-22 development team won the Collier Trophy, American aviation's most prestigious award. Due to the aircraft's advanced nature, contractors have been targeted by cyberattacks and technology. The USAF originally envisioned ordering 750 ATFs at a total program cost of $44.3 billion and procurement cost of $26.2 billion in fiscal year FY $1,985, with production beginning in 1994. The 1990 Major Aircraft Review led by Secretary of Defense Dick Cheney reduced this to 648 aircraft. Beginning in 1996. By 1997, funding instability had further cut the total to 339, which was again reduced to 277 by 2003. In 2004, the Department of Defense (DoD) further reduced this to 183 operational aircraft, despite the USAF's preference for 381. A multi-year procurement plan was implemented in 2006 to save $15 billion, with total program cost projected to be $62 billion for 183 F-22s distributed to 7 combat squadrons. In 2008, Congress passed a defense spending bill that raised the total orders for production aircraft to 187. The first 2 F-22s built were EMD aircraft in the Block 1.0 configuration for initial flight testing, while the third was a Block 2.0 aircraft built to represent the internal structure of production airframes and enabled it to test full flight loads. 6 more EMD aircraft were built in the Block 10 configuration for development and upgrade testing, with the last 2 considered essentially production-quality jets. Production for operational squadrons consisted of 37 Block 20 training aircraft and 149 Block 30/35 combat aircraft. One of the Block 35 aircraft is dedicated to flight sciences at Edwards Air Force Base. The numerous new technologies in the F-22 resulted in substantial cost overruns and delays. Many capabilities were deferred to post-service upgrades, reducing the initial cost but increasing total program cost. As production wound down in 2011, the total program cost is estimated to be about $67.3 billion, with $32.4 billion spent on research, development, test and evaluation (RDT&E), and $34.9 billion on procurement and military construction (MILCON) in then-year dollars. The incremental cost for an additional F-22 was estimated at about $138 million in 2009. Ban on exports. 2 F-22s during flight testing, the upper one being the first EMD F-22, Raptor 4001. The F-22 cannot be exported under U.S. federal law to protect its stealth technology and other high-tech features. Customers for U.S. fighters are acquiring earlier designs such as the F-15 Eagle and F-16 Fighting Falcon or the newer F-35 Lightning II, which contains technology from the F-22 but was designed to be cheaper, more flexible, and available for export. In September 2006, Congress upheld the ban on foreign F-22 sales. Despite the ban, the 2010 Defense Authorization Bill included provisions requiring the DoD to prepare a report on the costs and feasibility for an F-22 export variant, and another report on the effect of F-22 export sales on U.S. aerospace industry. Some Australian politicians and defense commentators proposed that Australia should attempt to purchase F-22s instead of the planned F-35s, citing the F-22's known capabilities and F-35's delays and developmental uncertainties. However, the Royal Australian Air Force (RAAF) determined that the F-22 was unable to perform the F-35's strike and close air support roles. The Japanese government also showed interest in the F-22 for its replacement fighter program. The Japan Air Self-Defense Force (JASDF) would reportedly require fewer fighters for its mission if it obtained the F-22, thus reducing engineering and staffing costs. However, in 2009 it was reported that acquiring the F-22 would require increases to the Japanese government's defense budget beyond the historical 1% of its GDP. With the end of F-22 production, Japan chose the F-35 in December 2011. Israel also expressed interest, but eventually chose the F-35 because of the F-22's price and unavailability. Production terminatio. Throughout the 2000s, the need for F-22s was debated, due to rising costs and the lack of relevant adversaries. In 2006, Comptroller General of the United States David Walker found that the DoD has not demonstrated the need for more investment in the F-22, and further opposite to the program was expressed by Secretary of Defense Donald Rumsfeld, Deputy Secretary of Defense Gordon R. England, Senator John McCain, and Chairman of U.S. Senate Committee on Armed Services Senator John Warner. The F-22 program lost influential supporters in 2008 after the forced resignations of Secretary of the Air Force Michael Wynne and the Chief of Staff of the Air Force General T. Michael Mosley. 2 F-22 is in close trail formation. In November 2008, Secretary of Defense Robert Gates stated that the F-22 was not relevant in post-Cold War conflicts such as irregular warfare operations in Iraq and Afghanistan, and in April 2009, under the new Obama administration, he called for ending production in FY2011, leaving the USAF with 187 production aircraft. In July, General James Cartwright, Vice Chairman of the Joint Chiefs of Staff, stated to the Senate Committee on Armed Services his reasons for supporting termination of F-22 production. They included shifting resources to the multi-role F-35 to allow proliferation of fifth-generation fighters for 3 service branches and preserving the F/A-18 production line to maintain the military's electronic warfare (EW) capabilities in the Boeing EA-18G Growler. Issues with the F-22's reliability and availability also raised concerns after President Obama threatened to veto further production. The Senate voted in July 2009 in favor of ending production, and the House subsequently agreed to abide by the 187 production aircraft cap. Gates stated that the decision was taken in light of the F-35's capabilities, and in 2010, he set the F-22 requirement to 187 aircraft by lowering the number of major regional conflict preparations from 2 to 1. In 2010, USAF initiated a study to determine the costs of retaining F-22 tooling for a future service life extension program (SLEP). A Rand Corporation paper from this study estimated that restarting production and building an additional 75 F-22s would cost $17 billion, resulting in $227 million per aircraft, or $54 million higher than the flyaway cost. Lockheed Martin stated that restarting the production line itself would cost about $200 million. Production tooling and associated documentation were subsequently stored at the Sierra Army Depot, allowing the retained tooling to support the fleet life cycle. There were reports that attempts to retrieve this tooling found empty containers, but a subsequent audit found that the tooling was stored as expected. Russian and Chinese fighter developments have fueled concern, and in 2009, General John Corley, head of Air Combat Command, stated that a fleet of 187 F-22s would be inadequate, but Secretary Gates dismissed General Corley's concern. In 2011, Gates explained that Chinese fifth-generation fighter developments had been accounted for when the number of F-22s was set, and that the U.S. would have a considerable advantage in stealth aircraft in 2025, even with F-35 delays. In December 2011, the 195th and final F-22 was completed out of 8 test EMD and 187 operational aircraft produced. The aircraft was delivered to the USAF on the 2nd of May 2012. In April 2016, the House Armed Services Committee, HASC, Tactical Air and Land Forces Subcommittee proposed legislation that would direct the Air Force to conduct a cost study and assessment associated with resuming production of the F-22. Since the production halt directed in 2009 by then Defense Secretary Gates, lawmakers and the Pentagon noted that air warfare systems of Russia and China were catching up to those of the U.S. Lockheed Martin has proposed upgrading the Block 20 training aircraft into combat-coded Block 30 35th versions. As a way to increase numbers available for deployment, on the 9th of June 2017, the Air Force submitted their report to Congress stating they had no plans to restart the F-22 production line due to economic and operational issues. It estimated it would cost approximately $50 billion to procure 194 additional F-22s at a cost of $216 million per aircraft, including approximately $9.9 billion for non-recurring startup costs and $40.4 billion for aircraft procurement costs. Upgrades. The first aircraft with combat-capable Block 3.0 software flew in 2001. Increment 2, the first upgrade program, was implemented in 2005 for Block 20 aircraft onward and enabled the employment of Joint Direct Attack Munitions (JDAM). Airframes from production Lot 5 onward are fitted with the improved and APG-77B-1, which incorporates air-to-ground modes. Certification of the new radar was completed in March 2007. Increment 3.1 for Block 30 aircraft onward provided improved ground attack capability through synthetic aperture radar, mapping and radio emitter direction finding, electronic attack and small diameter bomb (SDB) integration. Testing began in 2009 and the first upgraded aircraft was delivered in 2011. To address oxygen deprivation issues, F-22s were fitted with an automatic backup oxygen system (ABOS) and modified Lee-Fay support system starting in 2012. Increment 3.2 for Block 35 aircraft is a two-part upgrade process. 3.2 focuses on electronic warfare, communications and identification, while 3.2b includes geolocation improvements and a new stores management system to show the correct symbols for the AIM-9X and the AIM-120D. To enable two-way communication with other platforms, the F-22 can use the Battlefield Airborne Communications Node (BACN) as a gateway. The planned multifunction Advanced Data Link (MADL) integration was cut due to development delays and lack of proliferation among USAF platforms. The F-22 fleet is planned to start receiving Increment 3.2b as well as a software upgrade for cryptography capabilities and avionics stability in May 2019. A multifunctional information distribution system Joint MIDS-J radio that replaces the current Link 16 receive-only box is expected to be operational by 2020. Subsequent upgrades are also focusing on having an open architecture to enable faster future enhancements. In 2024, funding is projected to begin for the F-22 Mid-Life Upgrade (MLU), which is expected to include new sensors and antennas, hardware refresh, cockpit improvements, and a helmet-mounted display and queuing system. Other enhancements being developed include IRST functionality for the AAR-56 missile launch detector (MLD), and more durable stealth coating based on the F-35s. The F-22 was designed for a service life of 8,000 flight hours, with a $350 million structures retrofit program. Investigations are being made for upgrades to extend their useful lives further. In the long term, the F-22 is expected to be superseded by a sixth-generation jet fighter to be fielded in the 2030s.